Hello and welcome to the Lufft Academy webinar with the topic Lufft Passion for Precision. Before we will show you an interesting overview of all our application, I want to invite you to ask questions. You can see on your right side a box where you can type in questions, and please do so that we can answer your questions at the end of this webinar. So now I will give the word to our CEO Klaus Hirzel, who will guide you through the next 30 minutes.
So good afternoon everybody, ladies and gentlemen. Thank you for joining us this afternoon. My promise is we will have a clear end after 30 minutes. So Mr. Weil made the introduction. He helped me to prepare that short webinar, and we love to see some questions. I mean, we can talk over hours, but we prefer sometimes to see interactively what is your key interest. So please don't hesitate whenever you think something is wrong, something needs to be clarified, and then do us a favor and step in and send a question in. So our mission today is to give you an overview of Lufft, and mission means the long-term strategy of a company. What we have done over the last years was to reconsider our presentation material. Most of the information content today is real-time online. Refer to lufft.com and try to find what you need to know. That is a challenge today because we see some overload of information on some websites, and of course a website wants to show what we have. So which products do we offer, what technology is built in, how to use the products, how to talk to the sensors. So you see all the manuals, you see tons of information, but all what you see has to do with what we have. So we made our brochures in the last years in the same way what we offer. Now we are on the way to redesign the content of what we called printed material in the past. So we want to talk about why. Well, some people call that vision, some call that mission. So we can easily talk about why we do what we do. And that is the content of the new brochures which we offer. So it should not be just a giveaway and then after 5 minutes then we find a basket to forget it. So I think it has a little bit more a long-term view which we intend to give you. I wouldn't say that is a sales literature. Let's say it is the application background. And if we explain, let's say, what our users need, so then that helps to understand the applications in a better way. Interesting maybe for some of you is that we have excellent partners doing great business for Lufft in emerging countries in Asia. Some of them have asked me in the past, what is that on that title? They have never seen such a traditional instrument where people climb up and then measure temperature inside of a wooden case. So I think that is maybe a digital generation living in a digital century, but we have a long tradition. We should not forget how that weather archive was done over more than 100 years, and that is why we still continue to show that little bit old-fashioned picture on our title. So if we go into the first double page, then you see two key elements which drive our way of thinking. And it's not so clear what is the big and what is the smaller one of the innovation and imagination. We just found out in our German literature we did it exactly the other way around. So we said innovation is the big one, and let's say user first is the smaller one. At the end, the truth is in the middle. It is a real balance between the two. Of course, now innovation is a key driver for being successful worldwide. We see that innovation is an accelerating process worldwide. Innovation is not only happening in what we call mature countries such as Western Europe and in the Americas, but also now more and more in emerging countries. So we see good products coming from China, we see more and more excellent products coming from new countries. And globalization right now is in both ways, that new suppliers start finding markets in Germany, Western Europe, vice versa. All our way of thinking in all the cases was based on a global application level. So we are in a small market niche, and if we talk about meteorological, environmental data collection, then our representation of the industries has just 120 members. That's all. And a lot of them are very small companies, but highly specialized companies. Now, if you see what we do, we give you a little bit an overview on the right side here, and we talk about different markets. The very traditional market which we have since decades, that is meteorological networks. And meteorological networks always were financed by public money. So we all as taxpayers, we invested into the infrastructure to understand weather. That has changed over the last years. Now more and more private weather organizations go into applications where they have more knowledge with energy production, with road safety, with airport management, for instance. So we now see more and more sometimes a friendly cooperation between private weather companies and the National Weather Bureau. Sometimes it's not so friendly. So it depends on whether they do the same or they do some different things. So our understanding is most of the public investment has to do, let's say, with saving lives, taking care of people, managing extreme weather. A lot of that private weather applications have to do with managing machines under extreme conditions, such as a wind turbine, photovoltaic system, let's say an airport infrastructure. So different things. The one is B2B, where you have machines being managed under outdoor conditions, and the other one is a governmental topic where you need to understand your microclimate, your global climate, the climate change, and that is typically today a thing which a National Weather Bureau takes care of. If you see the pain or the targets of the users of those information, so we need safety as a human being. So the National Weather Bureau has to protect us in case of extreme tornadoes and typhoons. That means we expect precision, and precision in their nowcast forecast information. If you see an industrial way of thinking, they expect survivability of such an environmental sensor. That has to make a good job with a very high performance guarantee, which is typically above 99-point-something%. And so if you combine survivability and precision, that brings us to sustainability. Sustainable means use it over a long period of time and make sure that you have always good data. It's not good enough only to see that you receive a high quality sensor, but you have to understand the behavior over time. And whenever we see our industrial business, which we have done over the last 40, 50 years, our industrial users always were driven by understanding when a calibration is needed. Is it after a year or after 2 years or after 5 years? And calibration does not say anything about a product quality. It tells you how often there is a need to check the readings. And even if the readings are still good after 5 years, you have checked and you can confirm and you can tell your authorities at the end you have good weather information in the database, and they need good weather data to make good forecasts. So that is the combination which we do since quite long time, and that is for us an excellent background to combine the different things sensor technology needs today. So if we look into some of our applications, there is a target, and the target means better. So we have a status quo today, and a lot of our ways of thinking is, how can I change the status quo? How can I be better than the status quo yesterday? And you can call that optimization. Optimization in many cases means today save costs. Don't spray too much chemicals in your orchard. Don't use too much salt to protect the bridges. So you can save cost if you go from maximize into optimize, if you avoid unnecessary actions. So that is only one way for optimization. There's another way for optimization that means better. Not less, but better. So if you see that turbine on the picture and you have a better sensor to optimize the position of the turbine. And we say every degree counts. Every wind direction degree makes a difference. So if you have an excellent sensor telling you exactly where the wind comes from, and you put that sailboat or that wind turbine into perfect conditions and directions, then you are better. At the end, you make more money. You make more energy. So a lot of our ways of thinking in industry is to be better than what we have done yesterday. And so optimization means both ends. So save costs, but also optimize performance. If we see on the right side the weather extremes, flooded conditions, we are in a pretty mild climate zone here in Germany. In spite of that, we have seen a lot of extreme rain showers over that summer, and we will see more to come over the next years. Climate change means now don't rely on what we had over the last 10 years, just see what the weather will do in the next years. So historic models will not perform anymore. We have to understand what climate change produces in terms of more extreme weather conditions. For that, we need more data. Right now, maybe the density of existing weather points is not good enough to manage the requirements of human beings. We want to understand, is our home safe? Is our house protected? Or will be a flooding risk over the next 6 hours? So I'm only interested in knowing that for my building, not for the city. So that is one of the challenges right now national weather bureaus really have. They call that resolution 1 square kilometer. Give me a forecast per square kilometer. I have no idea how they do it. I'm not an expert in meteorological modeling, but that is even new to them. They have never done that in the past. Now the German Weather Bureau, they have started to give to public better resolution. If you give them more resolution, you have more risks that you fail. If you fail, people don't trust anymore. So that is now the higher risk they have. The German Weather Bureau, let's say, was very often criticized in the past due to wrong forecasts, due to wrong nowcasts. Now they go smaller with more resolution. It's easy to forecast. They might fail more often. And now they have an additional risk in the business model. How can you manage that? Use more data. Use more data points and rely on that you only have good data in your database to make forecasts for that. A private weather organization maybe will step away from managing extreme weather and protecting lives. So they will look into more B2B applications. How is it about energy production? How can we manage road safety? So what is now, based on the existing weather conditions, the right amount of energy people really need? So we only produce what the demands tell us. And we call that more B2B requirements. However, in that case, then you need to measure at the point where the business is. So they need additional networks for managing their B2B requirements. And that's, again, to combine precision and survivability, then to combine, let's say, a global weather picture together with a microclimate forecast. A special look, maybe just an example into road weather, into traffic weather. It's a quite interesting application for us, and right now in Germany we have around 1,500 road weather stations working in the 16 provinces. But don't expect that we have the same density in all the provinces. It depends on topography. It's not a surprise for you that maybe in Bavaria we have the densest network, we have the tallest mountains there, we have a lot of winter conditions in Bavaria. They operate 500, 1/3 of the total network in this province. However, the big disadvantage is that they, even with that density, they have not enough data points. Now they work on new research projects with driverless cars, and they need to understand each meter road conditions, not every 5 kilometers one point. So a mobile application needs mobile sensors. That's very easy to understand. We move as a driver with a vehicle over a motorway, 200 kilometers, and we have to get information about the driving conditions per meter. So fixed sites can never ever deliver. Algorithms can never ever deliver without getting mobile information back into the archive. So self-learning algorithms need to be bidirectional. I forecast that the bridge will be icy, but then a mobile sensor has to confirm right or wrong. And if my forecast is wrong, I have to look into the algorithms, why was that a wrong forecast. So we see a lot of mobile sensors in mobile applications. A runway is a stationary thing, but you have 4 kilometers and each airplane needs a different distance to stop the plane. So it's again somehow a mobile application. If you install a weather station along a highway, then it's not the same as to install a weather station for MeteoSwiss, for the meteorological observation, where they have a fenced environment. It's green, it's quiet, it's without any aggressive air. If you see the motorway conditions, it's exactly the opposite of all. So you need survivable technologies. You need maintenance-free technologies. You cannot just clean the sensor once a day. So our way of thinking here is that each application needs their special set of sensors to have a satisfying solution over a long time where you use the data. And traffic helps us a lot to understand extreme circumstances, extreme conditions. I would say the radar-based precipitation detection, which we have, would not exist without traffic applications, because that was the market where people said we cannot work with a tipping bucket, we will not work with any maintenance based precipitation detector, we need a maintenance-free device. And engineering said, okay, that needs a new technology, and we have started to use a radar that would have never come out of a meteorological application. That clearly came from a, let's say, B2B application, and now meteorological people look into that technology and tell us we need it also. We don't want to forget that we have an industrial business, and the industrial business of Lufft is 1/3 of our overall business, so we love that. We have a long experience with industrial products, and we have, in our opinion, very fine products with excellent precision. A lot of people trust in our products as a reference. We call these sensors then calibrators. So people use that as a calibration device in their environment, in their building and automation environment, in their pharmaceutical rooms, where they have clean room conditions. So they use our sensor as a reference sensor to say, is the humidity of the existing transmitter still in a good shape compared to our Lufft sensor? So we have a lot of experience with air quality, with CO2, with temperature, humidity, and all has to do again with calibration. A thing which is pretty new to environmental applications, but which is a quite standardized procedure in all our industrial applications, where people understand ISO means you get an instrument and you have to decide how often you want to recalibrate such an instrument. If we see our applications today, we see different levels which we have to talk about. The first thing, and that is how we start, is what information are needed, what sensors are required. We understand that the user has exactly the opposite view. How is my software view? How easy is it to get access to the data? How easy is to have a decision support system? So our angle is we start what needs to go into the decision making, and the user tells us how easy it is to use your system. So maybe both questions are extremely important. If we look into sensors, then we see today that all our technology which we use is pretty new, gives us new exciting possibilities. We talk about sensors today as smart sensors. Smart sensors mean there's a difference. We have a computer built in, and we use microprocessors in sensors since more than 10 years, but the new opportunities which we have now with FPGA means we have a kind of a mainframe computing technology in sensors. So sensors today are more than just delivering an output. They give you more messages, they give you a diagnosis, they tell you what is needed to go back into good data concerning calibration. So they do some kind of self-inspection. So expect a lot from sensors in terms of future technologies. Data recording in the past was important. Now we have a real-time world. That means we see data recording and data transfer combined as smart communicators. Smart communicators store some data whenever there is no coverage, whenever they cannot upload the data into a cloud. But as long as that is possible, maybe big data means that you receive a new data point once a second, or at least once a minute. Software means for us the user end, the friendly user tool, not studying manuals, but manage the data in a way to give a clear understanding of how the architecture was built. And apps means for us that more and more software tools will be mobile tools, not stationary anymore. So we have to follow where the decision makers are, and they have their mobile computing in the pocket. So we give them the data background wherever they are. There's one more point we want to mention, and so we are part of HMEI, the Hydrometeorological Equipment Industries, and right now we consider maybe to rename the organization to say it's better Hydrometeorological Enterprise Industries. So we have a business. It's not only equipment. We do not only offer a sensor, we offer solutions for people together based on teams, based on specialists working together with open interfaces. So the HMEI now looks into what they call metrology, traceability. Show me how you have calibrated your sensor. Give me a factory acceptance paper, or we come to do a factory acceptance test. So the procedure has to be clearer in future with environmental networks. The pharmaceutical industries, they practice a design qualification, installation, operation qualification, and a performance qualification. That is a quite good example how the meteorological industry will do the same in future. At the end, to verify on-site data are good. Calibration in the factory or in the laboratory. And to see validations of sensors, how long is the output a good one. And then what is needed to do it recalibrated again. So that is the last page of our introduction literature to say we have a kind of a mission statement herein. So we develop our products in Germany. As long as we develop the products in Germany, we produce the products in Germany and we calibrate the products in Germany. But we can verify products on site. We can verify products in all the various countries with certified partners. And we want to bring more after-sales competence to all our partners in the different parts of the world. It is not possible to return a sensor over a distance of 10,000 kilometers to do a verification or calibration. And that is right now more and more a key point for all how we design our products. So I have 3 minutes left on my agenda, and we have 3 slides left before we stop talking. Well, all has to do with future. Yeah, past is over, and where we stand today is what we present, how you see it. You can see that on the web. But let's say our way of thinking is what will we do in the next years? How is the measurement technology looking into the future? What is the expectation of our customers? We have only prepared 3 short slides for you. So that is one thing which will change the world, in my opinion. In our opinion, there will be not only one cloud, there will be millions of data clouds. And it will be, again, a Google competition. The best cloud will win. So the best content will win. And the best content has to do with best sensors. And we have already mentioned smart sensors. Smart sensors will feed the cloud. And then the cloud has a lot of data. Not only good sensors, also maybe some not so good sensors. So people now sometimes use 70, 80, 90 different inputs to feed a cloud with real-time communication. And now how can you use a cloud? So you have to, of course, qualify the data, but there's a business model where a lot of new industries and new players show up right now to say we have more options for users. So the second is here what we want to show, how we see future networks in environmental designs. So we see, let's say, the middle piece, that is the standard network which a National Weather Bureau operates, which in addition is operated by a private weather company. Right now they have started to try to find any temperature sensor which is around. Yeah, if there's someone operating a balcony temperature sensor, I take it into my database, but nobody has the reference. So they have their network, they have a lot of additional new inputs, but what about the key question, which one is right and which one is not so good? So you have to qualify and disqualify data, and that is a new part of the piece. And the German Weather Bureau tells we only believe in our data. But let's say a modern design uses any contents they can get, but then you have to qualify and you have to find a reference. And that is my last slide today for you. We have decided to build such a reference. And you can call it internally an S-Class Mercedes. And in fact, the price is nearly the same. It's not the same level as an S-Class, but for air temperature and relative humidity and air pressure sensor, whenever you exceed 5,000 euros as a list price, so that's sky high. There has to be a reason that people really need it and want it. And our view is that such a sensor is needed as a reference sensor. 30 minutes are over. Any questions left for today? Then we are happy to answer. And if not, so we have to thank you for spending half an hour with us. is there any idea for complete agricultural solution with leaf and soil moisture, temperature, precipitation, and so on? In fact, this is a good question. So we see today a balance between what we call individual sensors, only a temperature humidity sensor, or all-in-one sensors. Of course, we have a combination of sensors where you have all the agricultural sensors, including a leaf wetness sensor with a WS601 and the optional leaf wetness sensor. And then you have just to add soil temperature and soil moisture sensors. Our E-Class series is more on the high end of that application, so it's pretty expensive compared to what agricultural networks typically use. So right now we work on new smart agricultural sensors in the same way as we work for other applications. In a smarter technology means maybe not the precision which meteorological networks require, but which is satisfying enough for agriculture. So we can provide you with a WS601 right now, but you will see more options in agriculture over the next month from us. So that's all for today. Thank you for your patience. Thank you for your time. Have a good weekend and look forward to meeting you again next time. Thank you. Bye-bye.